No change.
Okay, this is Derwin King with ELC 215, electrical maintenance for automation systems. And this is February 18th, Thursday night. We're going to be covering the last end of Station 5 lab, answering one question, move on to Station 6, wrap it up, and then we'll start on looking at the IP addresses for the system and for the laptops so that we can go online using laptops to view the PLC program. A lab for Station 5. Okay, I gave everybody a graph set for Station 5, didn't I? I give everybody a graph set for 5.
No, that's the demand. That's a graph set? Is this a graph set?
Yeah. Did everybody get a graph set in Station 5? Station 5 graph set. Everybody get one? Everybody did.
That's really good.
Everybody did get one. Now, let me just tell you sort of in a nutshell, instead of taking time to go through the whole thing, you've seen it run. I'm going to give you a summary of what all of these lines mean. Very similar to Station 4. Station 4 has turntables with different things that go on at the same time when the thing runs. Station 5 is unrelated. So each, everybody listening good? Mm-hmm. Each device in each station on Station 5 has a subroutine on. Okay? So it's very simple. When you reach step 0, and you come down and you branch off, but you make sure everybody's got in front of them. Does everybody have the last set in front of them?
Yes, sir.
Everybody got it?
Yep.
Now, so basically, when you reach step 0, you come down. It branches off to step. It initiates step 10, step 30, step 40, 50, 60, 70, and then there's other ones on the other page. So step 10 starts a sequence for the feeder board, loading manipulator, and so on. Okay. Step 30 is for the inductive sensor. That starts where it turns in on before it can work. Step 40 is for the capacitive sensor. Step 50 is for the photoelectric for the photo light. Step 60, initial step of the measuring process, which is the stroke read the cylinder. Step 70 is the evacuator that goes and it gets the bad part out and it's going to reject. So each station has a set of logic to it that's initiated like 10, 30, 40, so on. So whatever section you have problems with, these numbers are going to tell you in the PLC program where to go to get you in the ballpark of the problem. So they're going to put you right on point. Once you get in the PLC program, you will go, for instance, to the area with start with 70 and following if you've got issues going on with this evacuator. Okay? So this is what takes you in the ballpark. Okay? If you flip over, at the same time that it left step 0 and initiated all those sections there, it also enabled 80 on the back page for the insertion process, which is right here. The part that gets it and puts it, inserts it into the block. So this device here is your insertion manipulator, and that's step 80 on the back. So if you've got problems going on out here with this thing, you flip over to 80 and following, and your problem is going to be more than likely visible in those steps somewhere in the PLC program, right? So that sort of gives you in a nutshell how you know, to make something so complicated look simple, to be simple. Because it actually is when you look at one little section of it at a time, you know. Whoever's out there watching, I'm going to shoot the graph set up there real quick and just show you what we're talking about, because I didn't have it visible for you. For Victor and McGill, whoever may be watching the recording. So I've got the graph sets where I can show those. You'll rotate. Okay, so whoever's watching the video out there, what I just told them, the graph set is this graphical flow chart that represents the entire layout of the PLC program that runs that station. So it gives you a graphic to understand the overall flow of the PLC program in steps, and those steps exactly match the steps that are in the PLC. So it's a really good way to help you know where to go in the program when you got problems. So those of you that are not with us, you will get a paper copy of this whenever you come. Okay, and that's all you need to know right now. Each section in here, 10 and 30 and 40, each of them are a section on the machine, a stopping point that has a function. Everything has a function. Okay, now back to answering the last question. Let's go back to here. Okay, so now there's one question left for Station 5, and we're going to move on. You explained the other night how the encoder's hooked up. That's 8. You explained the wiring of it. We went over that a lot. I'm not going to get into that again. The last question is this. We skip all of that stuff. You get to one question. We're going to skip the 9.3. Here's one simple question. What is the mission of the power supply source? The power supply. The power supply, if you go back to your schematic. So for instance, there's a power supply. You got, there's a couple of them here. So what does the power supply do?
Change the power from ELC.
It changes it from, in our case from 120 volts AC to what? To 24 VDC, yeah. It just converts the 120 AC to 24 DC for the controls, for the PLC, sensors, and the valves. Yep, that's it. That's the last question for 5. I'm going to hand you everything for 6 now. We're going to keep clicking. What you're looking at up right there is actually Station 6 schematic. So I'm getting ready to bring you one of them now. So there's 5. Yeah. Don't worry about putting all them definitions in. Let's just focus on just a little bit of stuff. Okay, here we are for station 6. And look, I'm gonna tell you what to skip because you don't need to put every little thing in here. You've done it so many times. Don't worry about saying all that again. You don't have to worry about saying all that again because you've done it, you know, like 5 times. Same thing there, skip that stuff. Just don't worry about none of that. Let's get on to something that's different about this station. There's one thing different about the station, that it has something new that the rest of them don't have. This section right here is what we're going to do, and let's focus on, well, actually there's 2 things that's new here that's not on the rest of them. And so let's go to the schematic. Now, so let's look good at this, at the schematic. Now, up in here, it's the same thing. 120 volt coming in. You have a power switch, an e-stop. Look closely. We're going to move really quick through this. You have a power supply that takes care of the PLC and the sensors and the valves. This power supply takes care of the conveyor motor. If you trace it out, like on the rest of them, that power supply is only for the conveyor motor for this station. There's a third power supply that's something different here. Now y'all look closely. Let's zoom in here. This is something that's new. Now we have, if you look at here, we've got the same 120 volt here coming in from the e-stop that it goes across there, the LO3 and NO3 and the ground. It runs over to a different kind of power supply. And I want you to tell me, what can you tell me about this power supply that's different? It puts out 5 volts, not 24. And what does it control?
Screwdriver.
It's a 5-volt screwdriver. So this little electric screwdriver up here, I got my hands on, it runs on 5-volt DC, not 24. And look, so you get the DC comes out of here, and wire number 05, it goes to a relay contact that's a Ka2 relay contact, and then it goes to a DC motor with straight lines, and then the common goes straight back to the supply. Let's trace out where that contact, what controls the contact. There will be a coil that controls the contact. So on every relay, you'll have a label on there, and you want to say, well, when does that come on? Then the key is going to be, where is the coil for Ka2 contact? So it's going to be on the last page of the schematic. So let's just go forward, and you'll see it on the remote I/O page. So it's going to be on behind the machine, back in there where you see the remote I/O up under here, where the Ethernet adapter card is where you're going to find it. Everything that's out near the conveyor is run off of remote I/O. Now, so here, if you look, this is on your page here, this toward the end. And what do you see? Now, over in here, you have the Ethernet adapter module that has the Ethernet jacks on it. It's in the little chassis with the input module and the output module. All that stuff is behind. You guys can see it up under here where I'm waving at, where the lights are blinking. You see that little module set with the lights up under there? Look at the output module. The output module is going to show us the Ka2 relay. So I'm going to enlarge in and let you see. We're going to zoom in. Was it Ka1 or Ka2?
Ka2.
Where was the Ka? I thought it was a. That's got me covered. Okay, so it's on a different, it's going to be on a different page. So it's not a remote I/O like that was it ain't on. It's not with remote I/O. It's actually on the local I/O up front. So if you look on page 5, it's on regular local I/O. Just back up one. It's been a while since I've looked at it, so I'm remembering wrong. So if you go here on page 5 there, you see Ka2. I'm gonna zoom in. It's on a regular local output. Let's take a look. Let's enlarge a little bit more. Now, look on the screen. What does that say there? Screwdriver on. What is the address? So local means, look, that output is on the front of the PLC with the CPU. Local means it's in the main front chassis where the brain is in slot 1. And what does O mean? It's an output. And which output is it? It's output 9 in slot 1. And again, So that's how you can interpret. You can look at that and you can know that it's going to be up front, not in the back. Okay, I was thinking that it was in the back because usually everything is remote out over back there. But evidently they didn't have room, and they didn't have another module. They could have added another module. I'm surprised they didn't. But if you follow this down, look at here. It's wire number 009. You follow it down, and what do you see? That's the coil. Now, in American schematics, that coil will be round, not rectangular. So, but on all of your international diagrams, if something comes from Germany, Italy, and in this case from Spain, this was built in Spain. It's European. Then they use international symbols. And like at Schindler, you know, Dylan, you use this your symbol for coils, isn't it?
Yeah.
So Dylan can tell you, Dylan wires this way for Schindler, and they're European-based companies. So all their coils are rectangular.
So I got a question. I can't remember off the top of my head. Tell me if I'm correct. With the American standard symbol, a motor, on the European, it's a circle, it's a motor. But on the US, it's going to be a circle with an N or something.
And they'll put a label on the inside of it, like M1, M2, motor 1, motor 2. It'll say M something. But anyway, in the 24 volt means it's a 24 volt coil, and the 24 comes from the PLC, and then it goes down to common. If you trace it back, it's going to go back to wire 25 for the common.
And that's in turn going to your A2 on your screwdriver.
It does, yeah. Well, look, this is a coil just for a relay, the relay. Let me show you the relay. Y'all look on the screen. I'm going to play around my camera here just for a second here. So this coil, the KA2 coil, it controls the KA2 contact. Let's go back to contact, and then I'm going to show you where the relay is in front of the panel. So let's go back to page 1, where the screwdriver is drawn, where the screwdriver motor is drawn. Now, does everybody see the KA2 contact? So this contact closes when on page 5, when that rectangular symbol, that coil, when it gets energized to 24, it makes that contact close and the screwdriver motor comes on. Everybody understand? That contact closes when page 5, when that coil gets energized from page 5, that closes, and then that screwdriver motor turns. Everybody understand that? Now let me show you where the relay, this relay KA2, where it is. I'm just going to put the camera down where it is and just show you.
Okay, there. Thank you. So your K2, that's going to be your common.
Y'all see right there?
Yeah. I was thinking it was. I was looking back. That has to. You get power on that, it's going to turn to take this.
Plugs into a base. You see right there? It's got a quick connect base. It's got a release at the bottom of it. That will release. If I do my thumb right there, it'll kick the relay out. If I do this, right there. If I push down on that, it will actually eject the relay out and kick it out. You see that, the blue coil in there? You see the blue coil in there? That's the coil. Okay? You see the wires up there? Let me get the. I'm trying to get where I can see the screen. You see the wire numbers there? That's wire number 05, and you get down there, you got your other wires. Wire 26 is so long. So that's your wires that you'll be plugging with the meter. Okay, everybody got it? Now, let's go back to the schematic. So that's one thing that's different, that's new. And there's one more thing. When you go look at it, all of your inputs, you got standard switches and push buttons and magnetic read sensors like normal. But you have a fiber optic sensor. You have a fiber optic sensor over here that has a standard symbol for a photoelectric sensor. So if we go right here, that looks familiar, doesn't it? From station 5, right? That's a photoelectric sensor or detector. It has light shines out of it and then it comes back in. But look, this time, this is not just a well, let me just say okay, everybody see the symbol. We know that it's a photoelectric. It's got light that comes out. It's looking for light to come back to say whether to get a signal. Now, this thing, if you go look at the PLC input, what does it say? Screw present. So this sensor is used to know, do you have a screw? Has a screw been dropped into a block for it to come get it and then go screw it in? So look, it detects to see, do you have a screw in place? And that's the symbol. Now let's flip to the actual device. Now right in here, y'all recognize these bigger cylinders here, they're drops. What's the problem here? These two cylinders, one of them is extended and one of them is contracted. They work opposite from each other. When that one goes back, the front one goes forward and it drops one screw down in the hole. When it does it, look down in the hole. You see that red light down in that hole? You see a red glowing light down in that hole. You see that? That's a fiber optic light. And here's how it works. Let's back up. You see this module right here? This module with the LEDs on it? Look on top of it, and what do you see? You see two lines going into it, right? Those are fiber optic cables. They're not wires, but they're fiber optic cables. They have glass line fiber in them that actually a light shines through the cable like it does in your neighborhood for your internet. A fiber optic internet, then this is a fiber optic line. Look, where I got the pencil at, that's a fiber optic line. One of them sends the light out and the other one brings the light back. So where did they go? Here's where they go. I want to get out here where you can see good. Let me change my angle here. Don't get seasick on me. Now, I think you're going to see it good now. Now back out and go here. You see in here, you got a fiber optic line that goes into here, into that block where that red light is. On the other side, you have another fiber optic line. So look closely here. Watch close here. On this side, you've got a fiber optic line shooting into that block through a hole. It shines through a hole in the block. The other fiber optic line takes the signal back. So this is actually fiber optic carrying a light beam. There's a light beam that shoots in one end of it over here through the block, and you see that red glowing light down in that hole, and it comes through here, and the other hose picks it up. The other fiber optic line picks up the light signal. And so look, if it drops a screw down in there, it blocks the beam. When it drops a screw, the beam will be blocked, and then the module where the fiber optic lines go knows when there's a screw there. So if you watch this, if you look down in the hole here, you see the glowing light down in there, right? That's the actual light that shoots through the hole. Now, right now, that light has actually got through there, and this hose here picked it up. That fiber optic line picked it up, and it brought it back to here. You see the LED's lit? Now, watch it closely. When I let it drop a screw, you're going to see the LED indicators change when you see a screw get dropped into there. You ready? So just watch the lights, watch the screw when it drops, and you're going to see the indication on the module. This is a fiber optic pickup module that sends the light out of one hose, and it looks for it coming back, and there's a relay in here. The relay goes to the PLC. Okay? Everybody see what I'm saying? You got here you have a two-piece, two fiber optic lines, one that shines it out, the other one picks it up, just like a garage door. On the garage door, you got on the bottom of the door, you got a transmit that shoots a light beam across. The other one picks it up, and if the light makes it to the other one, it lets you bring the door down. Okay. This works the same way, but it's got two fiber optic lines that are actually screwed into a block. So I'm gonna put it in manual. Let's get a panel over here. Well, I've got one right here I can do. So watch closely here. Now, what did you see happen? Hey, it dropped the screw, didn't it? And then the lights changed, didn't they? The lights changed. So listen, here's what happened. The screw went down in there, it blocked the beam, and then it lost the signal over here. So here's what you have. The PLC is looking to see when the screw drops in there and it loses the fiber optic signal, it knows there's a screw in the hole, okay? That's how it knows. Now let's let it index through and you're gonna see that change. Now watch it close here, watch it close. Did you notice with the pickers, I was gonna say notice the pickers. Watch the pickers when they go, they're always opposite. These two cylinders are actually plumbed in parallel, but they have the hoses opposite, so one is extending and the other one always retracts. They do a push-pull. So now we're over here looking at this, where it's gonna come get it. I'm just gonna jog it through. Come down, get it, go. So what do you see on the module now? They came back on and the hole is clear because, you know, the fiber can shine through. And so the module knows it's receiving light from the transmit cable line, okay? So it sees it. And the PLC is getting a signal down here. And the input for the PLC is input what? Somebody tell me. Where it says screw present. It's input what?
It's gonna be,
Right, input 12. Now, right now, there's no screw, right? There's no screw. Now watch this. Do you see input 12 on? Input 12 ain't on. Now somebody come up here and hit the button and let's get a screw in there, you'll see input 12 come on. Who can come hit the button? Now do it again until it drops the screw in the hole. Keep going. Again. 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 Now, you see 12 come on? You see 12 come on? 12's on now. Now look. And what do you see here? So you see the screw's in the hole, and it blocked the signal, right? So here's the way the module works. It's when you block the signal, this module is programmed to send voltage to the PLC whenever the beam is blocked. Now, so you have an option on this module for called light operation or dark operation. Look at here, I'm gonna open this up. If I open the lid up, you see the lid opened up right there? Open that lid up. And there's a mode switch in there. And let me see if I can get enough light on there where you can read it. Let me change where you can see down there further. There's a timer, and then there'll be a light and dark selection for light and dark. L and D. Now I'm gonna move it where I can get it way down in there. You see L and D. So it's set up on dark operation right now. If I flip that switch over to L, here's what it's going to do. If you put that switch on L, then it sends a signal to the PLC when it sees the light. But now on D for dark, when you put it on dark operation, what it does is it sends 24 volts to the PLC when it does not see the signal coming back. That's called light and dark operation mode of this module. You see it? L and D. There's a timer on there. We got it off. There's a min and max for sensitivity. The sensitivity can be set to be more or less sensitive to what it's shining through, so that you can fine tune there for sensitivity. And then, but let's say on a garage door, what mode would I need that in? Light or dark? Light. It had to be on L if it was a garage door, because you want to see the beam across the bottom of the door before the door can come down. In this case, you're looking for a screw to be in the hole, so you want to see it dark. So dark sends out 24 volts when it's dark, not when it's light. Everybody got it? That is a very important detail. I'm going to give you a data sheet on my module now, so you can have that. This is something that you may need to troubleshoot whenever I'm giving you bug. This, is on, that manual tells you about the features that we're talking about. You'll see all those features that are listed in there about the LEDs, the motor selection and all. The reason I'm giving you all this stuff, not just load you the paper, but this is stuff you need if you're going to troubleshoot, okay? It's stuff that you need if you're going to be prepared when there's problems, okay? Now, moving right along. There's nothing else that's unique about this station. We're going to click on now and start looking at Ethernet addresses for the system that you're going to need to know about for your laptop. Okay, we're going to do now, this information is going to go to your notebook.
Okay.
We're going to get into the address system and the Ethernet network of each PLC, remote I/O, and each laptop. You've got all the schematics in front of you for the system. Then we're going to start looking at very fast. Now, to make things very simple, when you have a network, we have a network in here, everything is connected by Ethernet cables. So on a network, everything has to have an address that's a unique address, just like at your house. Your address has to be not the same number as your neighbor. It can't be the same. You can't be at the same address. So if you look in this system,
So that's station 6.
no, this is for the entire system. So look, everybody listen good. Station number 1, the PLC itself, this is the address, 130.130.130.1. Station 2, for the bearing, that PLC has an address of a .2. Everything is 130s up to the last section, and it's a .2 for station 2. Station 3, the press has a .3, and then .4 for shaft, and so on through .6. These are addresses that were set up by the person that designed the system, and we're not going to change them. They're set addresses that are fixed, that you have to know what they are to go online with a particular PLC in the network. Now, when you use a laptop in here, they're going to be laptops. I have 6 of them. They'll be all around the room, and it doesn't matter what laptop or where you're at, you'll have full access to all the PLCs no matter where you are, because it is a network, okay? It's kind of like being on the freeway, and you have exit points to get to everybody's house. You can get to everybody's, to all of these locations from your Ethernet highway or network, if you will. Now, behind each station, there is a remote I/O, and each remote I/O has an address also. Those addresses are .13 through .19. And they didn't use 17 because they combined 2 stations here. There was a robot in the original bid, and we didn't have the money to get it. So they combined the robot. They replaced the robot with this screwdriver thing. Instead of the robot doing it, we run out of money, didn't have money to get it. So they skipped the address and put 2 things in one here, okay? But I've got a quote on a robot recently, and we don't have the money right now. So anyway, that's the addresses for the remote I/O. And then the laptops, my laptop has this address, and then yours is going to be student 1 through 6 laptop. And these are the addresses of the laptops. Those addresses have to be set manually. They're called static IP addresses. So I'm going to show you how to go in and configure into the laptop and actually manually set a static IP address. It has to be set. Everybody has to have a different address as you see on those laptops, or there'll be an address conflict in the system. And so that's our next step is we get the laptops out and I show you how to set the IP address on. That's the next step, okay? Because for you to communicate with the system, you've got to have a similar address, but it has to be different by at least 1 number. But all of them have to have those 130s in the beginning of it. It's the last section that has to be something different from each other.
Only one person can be in on the same address at a time, right?
No, everybody in here can be viewing the same PLC at the same time. Okay. And I'm going to have you do that. Okay. Like whenever you learn how to, our first exercise will be when we get far enough to get into the system, I'm going to have everybody to actually view number 1. And I'm going to step it through and show you how to follow the sequence in the program and see how it steps through the ladder logic. Okay. So yeah, it doesn't matter how many people want to get into the same one to view it, you can. So those are the addresses. And then there's something called a subnet mask that has to be the same on every computer and every PLC and every remote I/O. You got to have a subnet mask number of this. Everybody has to have the same one. It's kind of like it's a filter. Subnet mask is a filter that you got to have that same set of numbers in there as a filter to let you get in the system. Now, for me to break that down, I could break it down and show you in binary what it means, but it would take 45 minutes to explain what a subnet mask is. Just view it like this. And in very simple layman terms, it means it's kind of like this. It's to say that if you were going to go to a party and they told you you had to have a certain kind of mask on to get in, let's just say in crude terms that. You got to have a certain mask to get on to get in, okay? That's kind of a crude way to say it. There's a lot more to it than that, believe me. It's a filter. There's not time to get into it tonight. I'll try to explain it another night, really, the real mechanics of where that comes from and what it means. But every computer and every device, every PLC has to have a subnet mask programmed in of this exact code, or you can't get in the network. Okay, so then the next step is how do we set the laptop and give it a static IP address? Because a laptop normally has a dynamic IP address that where when you get on the internet, your server that you get internet from, they actually assign you an IP address, dynamic host addressing, to where whoever you hooked up with on the internet, they give you automatically an address every time you get on there, and you have no control over it. Now, I'm giving you an address for your laptop. You're going to lock it in called static, and it has to stay that way. And when you do that, you can't get on the internet with the laptop with the Ethernet. You're in a sub network, and you got to stay in here because it's a private network. Okay. So the next thing would be this. We're going to go over now. How do you set the IP address for a laptop? And then we set up a communication driver from the laptop to the system. So this is how you set up. Now it's actually 7:15 right now. It's 7:15 right now. What you can do is if you could actually do this in 15 minutes, but we need to do it. The computer's ready to stand here. We can get them out. You can set the IP address, but we got to get it wrapped up right around 7:30 or so to get them right back in there. If you want to do it now, we're going to wait.
I want to make sure we have plenty of time to get here.
Right, exactly. In a nutshell, I can show you, I'm going to go through the motions and show you how it's done. Okay. You can read along with me in here on the instructions, and I'll show you how it's done. Okay. And I'm going to give you a printout of the instructions. Probably the best thing to do is for me to show you where the IP. Well, let's yeah, we can go ahead and go through it. Go through.
Okay, y'all see my desktop?
Yeah.
Now, if you look at the lower left corner down there where my mouse is, you hit the start menu. Now I've got Windows 10. Your computers are going to have Windows 7, but you still, everything looks almost the same. Down here in the search bar, I'm going to look for something called control panel. Okay, there's an icon in Windows 7 for control panel, but actually it's right there. I see it right there. It was a recent thing. It was a recent search. So when you go into control panel, you're going to go into view network status and task in here. View network status and task. And then you go under where it says change adapter settings. Change adapter settings. And the adapters is going to be like communication adapters. You have an Ethernet adapter, and you have the Wi-Fi. Okay, those are communication adapters. Now here I can right click on the Ethernet adapter and hit properties. When you get into the properties of the Ethernet adapter, I'm going to hit Internet Protocol version 4. Internet Protocol version 4, and then I go properties. And what you see right here is it has the static IP address in there. You see it, the 130.130.100, and then it has the subnet mask in there, right? Now, this is the way it looks when it's put in properly. I'm going to show you how to get rid of it. If I was going to get on the regular internet, here's what I'd have to do. Instead of saying use the following address, I would say obtain the address automatically. If I say obtain an IP address automatically, then it's ready to get on the internet. Then when you hit your whatever if you're using your Google whatever, it will go out to your server. Your server's going to give you a dynamic IP address. It gives it to you. You never choose it. It's given to you each time you get online, and it can be different from day to day. Okay, so they actually lease you an IP address for a certain amount of time. It's done, that you don't see it. But again, that will be to get on the internet. You're given one, but now you got to specify one. Use the following address, and that's called it's called static. It's called a static IP address, and IP is Internet Protocol address. Okay, so you go in. Here's how you're going to do it. You will go in and you will manually put in the numbers: 130, 130, 130, and then you will put in your address for your particular look. Your laptop's going to have a sticker on, and it's going to tell you you've got student number 1 or student number 2, and then the address is going to be on there. My address happens to be 100. Yours will start with 101, 102, 103. Each computer has a different IP address. The subnet mask, you got to go in and give it another 255. And then the last section is 0. So you set that manually and hit OK. And then you close this. And then from that point, this laptop it has an address that it will be allowed to go online. It will be allowed to go online in this subnetwork. Next step, you flip the page on your handout. And does everybody have their paper that says how to set up RS Links Classic? Everybody have that? Everybody got that in front of them? So we're gonna go through that. Now, RS Links Classic, there's two software packages you have to communicate with the PLCs. RS Links Classic is one that lets the laptop connect to the system. And RS Links Classic is it functions like this. RS Links is like your cell phone carrier. If you're with Verizon or whoever you're with, or US Cellular, RS Links is the carrier of your communication. They carry the message through the Ethernet. You talk through it, the ELC talks to you, you talk with it, but you're talking through links. You talk through links. Links does other than relays messages back and forth. It's a carrier of your communication. Okay? So that has to be set up first. It's kind of like setting up your Verizon account. Now, the way that you set up the driver, well, the way you set up communications is like this. You go up here where there's an icon, and when you get the computer in front of you, it's going to be a lot easier. The third icon, it says configure drivers. You go under there, and I'm going to get rid of that driver. I'm going to hit stop and delete. Now, right now, I don't have a communication driver in place. I go under hit available driver types and go down in there, and there's a list of drivers. You got to pick the proper driver for the right kind of cable you're going to be using. We use an Ethernet cable. There's other types of cables. There's a list of cables in there for whatever type of equipment that you're going to be going online to. We're going to use a driver that's called Ethernet IP. Ethernet IP driver, I hit the wrong one. The Ethernet IP driver is called, it's industrial protocol. That driver is the one that gives the right protocol for your laptop to communicate with an Ethernet system through an Ethernet cable. It's got the right protocol to talk through Ethernet to this type PLC. So you choose that driver, and the driver is like it's a software package that has a protocol to it that talks for you, that communicates your message. So then when you choose a driver, you hit add new. This is the default name for the driver. We leave that alone. We don't change the name of the driver, even though you could. We hit OK. And then in this option, you choose Windows default, browse local subnet. Browse local subnet. I know this is all small up there. You get the computer in front of you Tuesday, you're going to do this yourself. Browse the local subnet instead of the internet. You're going to browse not something remote, but local. And then you hit OK. And it says that driver is running. Now, we see it running, but we want to find out, does it see all of the addresses in the system? So here's what we do. We hit close. And then we go to the driver and hit the plus symbol to open the driver to expand it. And we find out, does it see everything in there? And it does it because I don't have the cable hooked up. Somebody hand me an Ethernet cable from down there, if you will, one of those blue lines. Get me one, just a really long one. Yeah, if you'll find one that's got an end on it. If it ain't long enough, I'll get one of these over here.
Yeah, you may have to.
So like where you're at, you could be using one set about the table right here.
So if everybody, if you look, I'm going to show you how it sees all the addresses. You see how it populated that list? So it sees all the addresses of the PLCs. That driver sees everything in the system right now. And I'll say this, if I get up closer to it. My laser's a little bit weak now, but if you look here, this address is the .1 for station 1. That's where we're tying in through. This shows all the remote I/O. This shows the other PLCs. You have 130.130.1, 130.130.2, .3, .4, .5, .6. So all the PLCs are here, station 2 through 6. Station 1 is shown here. The other ones are the remote I/O addresses. So if your Ethernet driver has been set up properly, then when you hit the plus symbol, it will show you all the addresses in the system. That's as far as we need to go tonight. That this computer sees every address in the system. Okay. From that point, then you open up software that's called Studio 5000, and then you go online with a particular address. I'll show you how, say, station 1 looks to go online with that one station. So if I hit stop share. Go there. For RS links, I'm going to minimize it, and I'm going to open up Studio 5000. Studio 5000 is the icon up here that has a blue. It's a blue globe that says Studio 5000 right in here. That's the actual PLC software that lets you see the program, and it works through links. Now I've got Studio already open down here. These are the 6 programs for the 6 stations. Okay, and the 201 is station 1, station 2, and so on. I've already got the 201 opened over here, and I'm just going to show you what the program looks like. This is what the ladder logic looks like that runs the station. Now, if somebody can somebody go to the station and hit and step it through, and I'm going to show you how it looks when you step through the program. I know it's time to get out of here. It's at step 0 right now.
Which one are you on? First station 1?
Station 1. And if you look, it's at step 0 right now. It's getting ready to go to step 1. Right now, it's at step 0 in the graph set. The graph set lines up with this. You're getting ready to see it go to step 1. The screw feeding cylinder forward. Go ahead and hit it. Hold on a minute. Hold on a minute. I'm sorry. I'm not online. I'm viewing it offline. Let me go online with it. I had the program pulled up offline. You got to go in like this. Pick the address, and then go online. Now, I got green lights over here. Doesn't match.
Well, he's already started it. That ain't anything to do with it.
Got 1. Screw. What it is, I've got the screw program up here, not the 201. Okay, let me go out of here. Just give me just a second here. My bad. I had station 6 program in here. Let's go here. I'm on station 1 now. That's station 1, who active, and hit go online. Now I'm online with station 1. I'm on now, so he stepped it through to step 1. The feeding cylinder went forward. You see that? Now it's getting ready to go from step 1 to step 2, position verification cylinder downward. So hit it again. You see it? And the cylinder went down. You see, did y'all see the machine where it went down? The cylinder went down. Okay. Then the position verification cylinder will go up. Hit it again. The cylinder went up. The feeding cylinder will go backwards. Hit it again. You see it? So we're stepping through the program now, watching the ladder logic now. So let's go. It's going to jump to 5. The transfer cylinder went forward. Y'all see it go forward? What you're doing now, you're watching the actual ladder logic step through. You're watching it run, and you're watching the machine run, and you're seeing the ladder logic step through. Go ahead and hit it again. Transfer cylinder backwards. And then rejection cylinder, if it had the wrong, if the part was oriented wrong, it would do a reject, but it won't do that. It'll skip that. Hit it again. Insertion manipulator went down. Look at there. The suction cups went down. You see it? It's going to turn the vacuum on now. And then the manipulator went up. You see that it went up? So the suction cups went up. And then the manipulator is going to go forward. Watch it go forward on the belt. You see it go forward. You're stepping through the program now, watching it run. And basically, here's what you're going to be doing. When I start putting the buttons in, you're going to be looking at the program for where you can get to and where you can stop. And you're going to look ahead of these lines and figure out what is the missing. Is it missing this sensor? If some sensor not there, you've got to be different sensor. So if you slow down, put it on all the everything hit it at the component. So you can look at the missing things at the bottom. That makes sense. That's what we're going to be getting to answer to that. Now, we won't go too fast. We're going to get this short amount of time. But this is where we're heading. You see every one of the machines run. And you can find out where this process you are. Everything that will actually have to be made for the output. If you're going to be looking for different things, they'll be receiving these outputs. In other words, for the first thing to happen, everything has something that's going on that line. It's all something we're doing before things happen. It won't put you there. You see it next week. When you hit it again, you see what thing happens. And then I scroll down. And then it'll turn the vacuum off. Stepping on through. The manipulator comes up. You see it come up. You see the cups come up. They came up. Stepping on through. The insertion manipulator goes backwards. And it let go of the part. So it just in a quick way, you watch it step through. You're going to take your own time, nice and slow. Nice and slow. You can learn how to do what I just did to get in there to follow the program through and troubleshoot the logic that runs the machine. Okay? And you're going to learn a lot. You're going to learn a lot. There's a lot going on. And if you will get good at this, and that's going to help you be good wherever you're at doing the same thing by having a lot of practice with this, because from here on out, every night's going to be troubleshoot. The rest of the semester is going to be troubleshoot. It will be. Yeah, a lot. Mm. You're going to get very good at this. You're going to get very, very good at this, and wherever you go to work at, it's going to benefit you. Okay. Okay, I'm going to cut the recording off so it can process, and I got to get out of here. So whoever's watching, have a blessed weekend.